Hello everyone. In this session, we are going to talk about how to identify poorly performing measures, relationships, and visuals. So, optimizing the performance in Power BI is very crucial for providing a seamless and efficient experience, especially when working with the larger data sets and complex reports. And there are few steps that you can do and you can use to identify and address some poorly performing measures, relationships, and visuals. So, if you talk about how to identify the poorly performing measures, the first one is that you can inefficient time. You can use the Power BI's performance analyzer to record and view the time taken by each visual to query, render, and perform other actions. Measures with high calculation time can be pinpointed in this part. The other part is you can simplify the text formulas. So in this, you can use some complex formulas sometimes, and that can basically slow down your process. So in that case, what you can do is you can simplify these formulas whenever possible or break them into simpler, more efficient calculations. Then the next one is avoid iterative functions. So iterative functions like sum x and average x and other formulas can be resource extensive. Use the aggregation functions like sum, average, etc. whenever there is a need or whenever you can use it possibly. Next one is using the variable. So variable can be used to simplify and optimize the text code. They allow the calculations to be performed once and reused, reducing the redundancy and improving the performance of your model. The next one is optimizing data models. So ensure that your data model is as efficient as possible. Remove any unnecessary columns and tables and use appropriate data types. The next one in the list is how can you identify the poorly performing relationships? So relationship between the tables are fundamental to how data is combined and analyzed in Power BI. Inefficient relationships can lead to slow query performance. So you have to examine how relationship cardinality is there. So, for example, relationship with high cardinality, that is many to many connections, can be more resource extensive. So, wherever possible, simplify these relationships to one to many or many to one. The next one is review cross filter direction. Cross filter direction in bidirectional relationship can complicate and slow down the queries. Ensure bidirectional filters are necessary and consider switching to single direction filter if possible. The next one is check for redundant relationship. So redundant relationships that aren't necessary for your analysis should be removed to streamline the model. And then the last point over here is optimize the lookup tables. So you have to ensure that the lookup tables that are basically the dimension tables are optimized for performance. This include minimizing the number of columns and ensuring that the columns used in the relationships are indexed properly. Now moving to the next part, that how can we identify the poorly performing visuals? So in this, the first thing that you can do is you can analyze the visual performance. Again, use the Power BI's performance analyzer to access the performance of each visuals. Visual take a long time to render, that can be identified, and then we can do something about it. The next one is limiting the data points. So too many data points can overwhelm sometimes the visuals. In that case, what we can do is you can use the filters, slicers to summarize these data points. Also, you can remove some data points if they are not needed. For example, if you are creating a scatter plot, in that case, there are too many data points. So if you are not needing some data points, you can basically remove those. Then the next one is optimizing the visual type. So again, as we were talking that some visuals are more performance intensive than others. For example, again, scatter plots with thousands of points can be slow. So you can consider using some alternative visuals or aggregating the data in that case. Then we have reducing the number of visuals. So if you are having too many visuals in a single page, that can slow down the performance. So whenever possible, distribute the visuals across multiple reports or tabs. Then we have using the custom visuals sparingly. So you can use the custom visuals sometimes, and that times it can be like more performance intensive than built-in ones. So use them only when they are very necessary and ensure that they are properly optimized. So these are the things you can do to identify poorly performing measures, relationships, and visuals. Identifying and addressing these performance issues in Power BI involves careful examination of measures, relationships, and visuals. So using tools like performance analyzer, simplifying text formulas, optimizing relationships, and managing visuals can significantly enhance the report performance. By following the best practices and regularly monitoring the performance, you can ensure that your Power BI report remains responsive and user friendly, providing a better experience to all the users. If you are not sure how to do these things, what we can do is we can go quickly to Power BI and we can see how can we do some of these things to enhance our Power BI's performance. So for example, right now I am having all these visuals over here on my report page. So the first thing that I can do is that I don't want to present this report for now. So I can distribute these visuals on different pages. So over here I'm having these pages. So what I do is I can easily just distribute them to various pages. For example, let's say that this is more resource extensive. So I'll copy this and maybe paste it over here. Whenever needed, I can come back over here again and make some necessary changes. So this would distribute the load evenly and you can always remove it from here. The next part is that whenever you are working with any visual, you can go in this view tab and you can find this performance analyzer over here. Also in the optimize part, you can find this performance analyzer. So again, you can go to view tab or optimize tab. And over here, I'm having multiple other options also like pause visual. So what this will do is that whenever you are making any changes to any specific visual. So for example, let's say that I'm taking this visual and whenever I'm making any kind of changes to it. So right now it is taking the average of sales by region. So in case of any other changes, for example, let's say I want to find the sum of sales. So what I'll do is I'll change this average to sum over here. So how to make this, we will also look at it in the upcoming session. And this has now been changed to sum of sales by region. So you can see the numbers of this particular visual have also changed. So let's see over here. Right now it is showing 1.6 million. So I'll just expand it. And whenever I'm making any changes over here, so again, instead of sum, let's say I'm taking average. So you can see the numbers are being changed. So it is optimizing that particular visual for you according to the changes that you have made. Now, what would happen if I pause this visual? So since you have paused this visual, now whatever changes you will be making. So again, instead of average, I'm saying minimum. You can see there are no changes right now. And it is also telling you that the visual changes has been pending. So these changes are pending right now. And how would you then correct those? So for that, what you can do is you can go over here and unpause this visual and then you can refresh this visual. So now this visual has been refreshed. You can go back to the report. So whenever there are multiple changes in the visual and you just want to change them and not look at that visual right now, because these can be time consuming process. So in that case, what you can do is you can just simply pause the visual, you can make the changes and then you can refresh the visual. This would optimize your performance a bit. The next part is this performance analyzer. So what I can do is if I click on this performance visualizer, here I have this option of starting the recording option. Now what would happen in this performance analyzer? I have the option of starting the recording from over here. So I can start the recording. And what would it do exactly? So let's say if you are making the changes to any visual. So again over here, let's say I don't want to take the minimum of sales by region. I want to change it to the sum. So I can click on the sum and you can see that the time it took in the milliseconds was 789. So in this way, you can find the changes time in each visual. Again, let's say if you have made any changes to the data and you want to see how much time each visual took to load. So for that, what you can do is you can go in the home option and let's say I'm refreshing my data. So I can go over here in the refresh option and click on refresh. As it is trying to load all the data, it would also try to refresh the visuals. And all these things can be recorded in the performance analyzer. So you can see it is trying to load all the data sets that have been loaded currently. It is basically trying to refresh them again. Any changes that you will be making in those data sets would be reflected over here. So you can see that we have changed the model and it took this much amount of time for each visual to load. So in this way, you can use the performance analyzer. You also have this option of refreshing the visual from over here. So you can directly click over here and refresh the visual. And without refreshing the data set again, you can simply refresh each visual and you can find the time it took to refresh that visual. If you click over here in the plus option, you can see what were the things associated with that particular visual. So for example, was there a text query involved? What was the visual display time it took? And what were the other particular things that were responsible for refreshing this visual? All these things could be find out with the help of this performance analyzer. And then you can find out that which part is taking majority portion of the time. For example, over here, you can see table was the one which was taking maximum time. Again, in the second part also, when I refresh this visual, table was the one which was taking maximum time. So you can try to find out what is the specific thing in the table that is taking the maximum amount of time. If you want to export this data, you can export it with the help of this export option, and it would export this file in the JSON format. To clear this, you can click on clear and it would clear this for you. And to stop it, you can click on stop. Suppose if you don't want to analyze this performance anymore. Again, you can go to optimize options, and you also have this option of optimizing your presets. So this was a part in which you can try to identify which particular visual or which particular option is taking maximum amount of time. Then the next thing is identifying the relationships. So if you go in this model view, right now I have loaded few data sets. The first one is the orders, then we have peoples and returns and the date table. All these are connected to one another. I have defined some kind of relationships over here, and that's how they are connected. Now let's say that right now I am not interested in creating any visual which involves these relationships. So for example, using this returns and orders, I have not created any kind of visual over here. So basically, if this is not needed, what you can do is you can just remove this relationship for now. Also, you can see there is this many to many relationship created. This many to many relationship is very resource extensive, and you have to use a bridge table over here to define it. So in this case, what you need to do is you need to change it to, you can go in the properties. So basically you need to change it to one to many or many to one relationship. Now also, this particular relationship is not having this cross filter direction correct. It should be used as single. Either orders would be filtering returns or returns would be filtering the orders. If we are using this bi-directional, then it can be again resource extensive. So you can use only one of them, whichever you need. If you need both, then that is a different case, and that can also cause a ambiguity in the data. If this relationship is not at all needed, you can delete this relationship. So this is a second way. Again, let's go to the table view and see how can we do some changes over here. So for example, I'm working with this sample sales data. Now in this sample sales data, I'm having these three columns of unit price, quantity, and the total sales over here. So this total sales column, I have created it. It was not existing there previously. So instead of creating this total sales column, I could have also used the sumx function. Now we have already talked about the sumx functions. Sumx function would do row by row operation and then give you the total. So for example, if I want to find out the complete total sales, which is the basically summation of this total sales, how can I do it? I can use the sumx function, and there I can define that I want this quantity column to be multiplied by unit price column, and whatever output you get, you have to sum it all. So basically that aggregation function was a iteration kind of function, which was iterating over each row. Instead of using that, what I did was I have created this custom column, and I have defined this custom column with the help of text function. Now this would be less resource extensive, because whenever you are making any changes, again it would be doing some row by row operation. So you can use these kind of things instead of using the iteration functions whenever possible. Also, you can delete some unnecessary columns. So for example, let's say that I'm going in this orders table, and this data set contains too many columns over here. Now I'm not sure that I'll be using all these to create some visuals. They can be necessary, but let's say that I don't need that visuals. I don't want to perform any aggregation operations or any kind of operations on the top of them. So in that case, what I can do is I can delete those columns also. So for example, I don't need this row ID over here. So I can select it and I can basically delete it. And since there are 51,290 rows, so it would save me a lot of space also. So this is how you can identify poorly performing visuals, measures, and relationships, and you can optimize it. This was all for this session. Thank you.